Hey guys, today we are doing this fun experiment.
Make a glowing test tube. Yes.
So, measure 50 milliliters.
But this is, again, from the National Geographic Mega Science Series, Amazing Reactions.
This water is steaming hot.
Oh, good. It needs to be warm water. Because they said
It's
use
hot.
50 milliliters of water in the
Not
beaker.
hot
They said
water.
warm water.
This is hot water, feel it.
All right. I think it'll be all right. But get 50 milliliters. You got 50 milliliters in there?
Over. I hope it doesn't melt this.
Bring it over here to where
I hope it doesn't melt this.
It is not going to melt. It is not that.
Oh, that's... Okay.
Are we at 50?
Just at 50. Actually,
Right at it?
one drop below.
Oh my goodness.
Has to be just right. That's.
Okay, so now
That's steamy.
it says to add 1 medium scoop, which is this guy right here,
Make sure it's in
of
dry.
the zinc sulfide, and I guess I need my leveler. Let's find it. It's wet. You can't do that. You can't level a dry thing with a wet something because it'll stick. Zinc sulfide right there.
Oh!
Be careful. There is nothing in there.
How about now?
No, hardly any.
What? Oh, that's not enough.
No. Oh, careful. That isn't going to be enough either.
I don't think there is enough.
That's good. But you need to, if you could, we need to make that bigger like that where I can level this. If you can move it directly over the middle of that. It's on the edge. It's spilling right out. Okay, so now pull it out. There you go. That is perfect. So let me help with that.
Into this?
And we're going to pour that into
this 50
short cup where we're
milliliters.
supposed to be, okay, so,
There's nothing in it.
wait, it says add it to the test tube. Oh, so add the 50 milliliters of water to the test tube, but put that into the short cup. So they said to spread that out evenly, which you can do by shaking it around a little bit.
Let me.
Make it kind of an even spread around there. Tilting it a little too much. It's hard. So why don't you pour the 50 milliliters of the water into this test tube? How about that?
Make sure
You
it's
can do
warm.
that.
It's warm. Well, that's almost the whole entire test.
That's really hard to get even because it's got indents on the edges. It's like, how are you going to do that? Okay, so let's just see. Let the powder sit directly under a lamp or UV light for 1 to 5 minutes. As bright as you can get it. Make it as bright. Is that on the brightest setting? Yes, I guess it was. Whoops. There we go. As close as we can. Ooh, I see it turning yellow as we're doing it. Let's see, it actually has a yellow tint to it.
Stop. Just leave it alone. Just. Oh, Oh.
Okay, so it just said from 1 to 5 minutes. The longer it absorbs the light, the longer and brighter it will glow. So, it's called... Okay, so what's going to happen, of course, is hopefully that test tube is going to glow once we add it. It says once we've held it under there long enough, we would add that powder to the test tube and stir for 30 seconds. But leave it... Oh, I think I see it glowing already.
Oh, it is! Whoa.
Cool. Awesome. So that is zinc sulfide glowing under the light. That's pretty neat. So in luminescence, an energy source kicks an electron out of its normal stable state into... You gotta add it... Oh, you just want to see the powder glow? Here, let's turn off this light and have the powder glow. We can
It's glowing!
see the powder glowing.
Oh my God.
And we haven't even added it to the test tube. So, of course, once we add that to the water, the water's going to glow.
Light on.
So that is awesome. All right. So keep doing that, and I'll explain what happens here, what will happen. So in luminescence, an energy source kicks an electron out of its normal stable state into a higher energy excited state, and the energized electron gets rid of the extra energy in the form of light so that it can fall back to its normal or ground state. In a phenomenon called phosphorescence, the light energy is stored and continues to be emitted even after the original source of energy is removed, such as that light. And what is phosphorescence? Well, shining a lamp on zinc sulfide provides added energy that excites the chemicals electrons. Because the electrons take
It's glowing even on the light. It's glowing.
Because the electrons take a while to relax back to the normal state, the glow lasts even after the light is removed. The more energy that's absorbed, that is, the longer you leave the zinc sulfide powder under the light, the longer the glow will last. Once the glow fades, you can recharge the solution by putting it back under the light. However, since the water in the test tube will absorb some of the light's energy, it may take a lot longer to get the solution to glow again. But that's so awesome. So you want to make the test tube glow now? Are we ready for that step? Zinc sulfide's cool stuff, isn't it? That's glowy stuff.
It's glowing right now.
I know. Look at it. It's so awesome. So you're going to add that and stir for 30 seconds. Whoa, powder everywhere. We're going to have probably glowy countertop. Ooh, I bet that would glow too.
Wait, not now. Not now.
Why? It'll glow at the same time. That powder. What? You got it?
I was talking about that.
Pretty much?
No, not yet.
I think that's good enough. Oh, you want to shake it. And then we got to go ahead and turn the lights off and see it glow before all the energy's used up. Awesome stuff. All right. So, are you ready? Are you ready to watch the glow? You got to go turn that light off. And I'll turn this one off. Let's do it. Ooh. A glowing test tube. And the glowing powder on the countertop.
Oh, and this glowing.
Let's see. Oh, yeah?
I have the power.
I can't see. Hold on. I can't see it. Because we're in the dark. Glowing test tube. That is an awesome experiment. I like it. Can't really see that powder. Can see that powder though. All right. Well, that was.
Oh, it works as a glowy stick. It works as a glow stick.
It's too far away for me to see. Okay, it's too.
Let's recharge it.
Okay, well, this can't detect it. Yes, it sees it more strongly in the powder form than it does when you add it to water because it's diluted in the water somewhat. It's more spread out. And like it said, the water is absorbing some of the light's energy, and that is why it isn't as bright when it's added to the water. Okay, last time.
Cut the light off now, in a minute.
Last time.
Now. Cut it off now. So, I am done.
Last time. Ooh, now I can see that powder too in the cup.
Oh, no way! Oh.
And, well, ooh, on the spoon.
What happened? Wait.
And on the
Whoa,
counter
wait.
and the test tube.
Wait, I have an idea. Wait. How much of that can I get? Whoa.
It has gotten to the point where I can't see it. Ooh, look. Cool, that's the residue. Most of it stayed in the test tube once he poured it into a cup.
Actually, it's not residue.
All right. That's so cool. It's dripping on the counter. I see blue. No, not blue. Green. Green glowing drops on my countertop. And the powder. That is so cool.
What happens if I pour it down the drain?
It'll just be glowy solution down the drain.
Oh.
All right. So this camera.
Whoa!
Right.
Whoa! What?
This camera can't see anything
Wow.
now. Okay. So the audience is just left with a darkness right now.
Whoa! It feels so weird.
All right. So
It feels like sand.
that is it
It
for
feels like the
our
finest sand in a while.
make a glowing test tube.
Well, that was fun.
And our battery will die if we don't say goodbye.
Bye. Please like and subscribe.